right. Welcome to another episode of Startup Conversations. I'm your host, Roderick Bates, and I am absolutely delighted that you are joining me today to hear from a very interesting startup. I guess maybe past the startup part, but it's still starting, still making big moves. I'm here with Jack Rusk from C.Scale. So, Jack, please introduce yourself. I never like to introduce other people too much because you might miss the important parts.
Really excited to be here, Roderick, and excited to talk about C.Scale. We spun out, formed the company in 2024. So I guess it's been about a year and a half actually now, because it was December, end of the year, December 2024. That happened. A lot of the work behind C.Scale actually started in practice. I was at EHDD, an architecture firm in San Francisco with a long history of net zero projects, and really trying to figure out how to make better material decisions earlier in the process and understand the climate implications, the impacts of those decisions. And it was really fun to incubate this research project, really like grounded in practice, and even more fun to spin it out from EHDD, raise some money from some awesome investors in the US and Canada, and build something not just for a few firms, but for the industry. And I know that you've had your own journey incubating tools within the context of architecture firms. And yeah, I think there's a really parallel journey actually, with
Oh, there
C-Scale.
definitely is. I mean, there's some things that I wanted to ask you actually, like difference between starting an LCA carbon accounting tool in 2024 versus 2010, and sort of the difference in knowledge. I remember we did a survey where we asked people like, "Do you know what LCA is?" And I think we sent out to some like 2,000 architects, and I think something like less than 30% even knew what
Hmm.
the heck we were even talking about, which is kind of wild to think of how far the industry has moved. But you mentioned
Absolutely.
EHDD. So for those that aren't familiar, awesome firm. It's like if you ever look at the code top 10 from the AIAs, the top 10 green buildings every year, it's like something's wrong if there's probably not an EHDD project on there.
That like, yeah, that what, it's a, we'll say like a, what I think these days might be considered a small firm. I don't know, like 80 to 100 people in a
Well,
given
that's a
year.
lot. I mean, most firms are actually like 1 to 2 people. So I don't know. It kind of
Okay.
depends on.
This is another like dynamic in the industry though to discuss is there's a lot of consolidation happening.
Mhm.
So there's this middle ground of firms between larger than 20 and less than 200 and trying to find their place in an increasingly competitive market. We think it's one of our theses that easy to use building performance tools can make these mid-sized firms more competitive. But for EHDD, like they're, that what people say internally, it was the most code awards per head count. I don't know if that's
Nice.
still true,
Yeah, this
but
is
it's
like
sort of
those
like,
universities are like, we have the most Nobel laureates on staff or something like
yeah,
that.
maybe not an absolute number,
Yeah.
but per head count, trying to
Nice.
punch
Yeah, you
above
always
the
got to
weight.
work on the metric there. But they did one of the coolest projects, I think, out there, and people have not been to this building. It's the aquarium in Monterey Bay. It
Hmm.
was an older EHG, probably before your time,
Hmm.
but just such a cool project. And the idea of incubating a technology inside of a firm like that, where they really care about design, they really care about sustainability. I imagine that's like kind of that's a bit of a crucible. Like if you can meet the needs of a firm like that, it probably sets you up pretty well for the larger market.
And in, that process, we really were looking towards the research group at Kieran Timberlake that you were involved in the years previous as really a model of of research integrated practice. There's all sorts of ways where obviously like, if you are an architect and you are designing, every project is unique and there's a sort of dimension of research actually that's just part
Mhm.
of design. But then to really think about research as a practice, we'll say like on its own terms within the design context, Kieran Timberlake had an amazing research group and program. And it was a very clear precedent for us that proved that it was possible to do interesting,
Nice.
meaningful industry facing research
All right,
within
well, so
the,
people
context.
may not know like what my history is, but I actually was a principal at an architecture firm a number of years ago. I was in a research group at a firm called Kieran Timberlake a number of years ago, and I was actually when I started, I was actually I was the first member of the research group. The
Wow.
original research director had left to go join an appointment at Cornell, I believe, maybe, or Syracuse. And so I was like, okay, I guess I'll do this. And then of course we had a proper research director join, and we built it out from there. But my maxim for hiring was always find the smartest people possible that were still socially functional. And that was like, and we ended up with the best crew. It's like this incredible, very smart, very social group, and it ended up being just the right dynamic. And we developed a software that we had called Tally, which was kind of wild because when I reached out to you to have you come on Startup Conversations, it turned out like this wasn't something that was in the news at the time. And you said, "Oh, there's
Hmm.
something big that I'll want to talk about." And then I saw the news that C.Scale had acquired Tally, which is huge from my perspective. And I was like, oh, wow, there's a full circle moment. So maybe you can explain a little bit for the audience that's not familiar, what does C-Scale do? How are people using it? And then, what does Tally do? And then how do you see these two things starting to come together?
Yeah, that's awesome. So, what we've really been working on since 2019, 2020 with C-Scale is helping people make better decisions from a whole life carbon perspective, materials, energy, refrigerants, construction, the whole kit and
And in the
caboodle.
context of buildings,
In the
obviously,
context of
for
buildings,
those that may
buildings,
be
buildings,
totally ignorant to
buildings,
what we're talking
buildings,
about.
buildings, buildings, you know, everything that what matters most so that the design budget and the time that they have is targeted towards
And
high
how much can it
impact.
matter? Like, how
Hmm.
bad of a decision can you really make when it comes to materials?
Well, I'll say, a few ways to slice that. There's the global statistic that gets trotted around. I think, maybe to the point of it getting kind of flat, where 40% of
Mhm.
global emissions are
Is
related to the
somehow
building
related,
sector,
right? And that's a
is
little bit of
somehow related.
operations, a little bit of the materials
11 to
themselves.
13% is maybe the materials,
Mhm.
the remaining 27 from operations, squeaks one way or another year over year. Um, there's other statistics that I think are a little more powerful. When you look at the impact of design decisions, right? Like made by professionals. Designers have a sort of like a purchasing power represented in their professional choices that's more than 100 times greater than us as individuals. So you
I mean, it's
or
gotta be
me,
even more than that though, right? Because I think of, like, I go to the grocery store or whatever, I
mhm,
like everything that comes through the door of my house, I can pick up and move. Whereas everything that comes onto a building site, I'm not even able to move it.
like, every little line drawn on, or 3D element, right? Like in BIM, all of these move global supply chains.
Yeah.
If
It's
there's
a
like,
lot of
and
responsibility, isn't it?
it
Like, I
is,
don't know
yeah.
if people really appreciate how much responsibility they have, and, like, their decisions are having these cascading effects, and you're right, it's not just how much it costs, it's, okay, what's the actual impact from an
Hmm.
environmental perspective? So how big is, and if so, let's say you said it was like 10 or 11% it can budge this way or that. I'd be curious, from your perspective, if everyone made really bad decisions, where does that put us? And everyone made really good decisions, where could that put us?
I'll like, to draw out a wider comparison between us as individuals
Hmm.
and the scale of the building. If, I can choose a vegan diet, say, like there's a lot of good vegan food out there. I
Hmm.
live in New
Oh
York
yeah, but you
City,
live in the city, in New
lots
York
of good
City, so
options,
yeah,
Hey, like that transition to a vegan diet, 2 tons ish, of CO2 emissions like prevented a year
that's
from
pretty
that
big,
choice.
right? Yeah.
Over, we'll say, like, I want to live at least 50 more years would be really nice. About 100 tons total for a mid-sized commercial building. If we're able to, decrease the concrete use or the carbon emissions of concrete by 5 to 10%, we're looking at saving sometimes of 500 to 700 tons of, and this just means like these tiny decisions, these incremental choices we make at the scale of a building immediately outpace and outstrip even the most, life altering, lifestyle altering decisions we might make
What I
as
love
individuals.
about that in some ways, though, is if you ever want to like convince a client, people are always like, "How do I convince a client of this?" I love this idea. Be like, "Well, either you become a vegan or you approve of this different material."
And it is like the thing that I think keeps us going. I think we'll touch on this in different ways in the conversation. Is professionals realize or are aware of in different ways the impact of their work, and architects are good at thinking about the way a building shapes neighborhood character,
Hmm.
shapes the life, and the comfort, the sociality of people within it. And I think people realize that you walk a construction site and you see the pallets of materials, you see the trucks coming in, you see the laydown areas. People ask the question like, where does all this stuff come from? And why
All
is
over
it
the
the way that
world.
it is? And it's like reckoning with those facts.
Hmm.
The we'll say like all sorts of ways to ask questions about where materials come from, what the impacts are. I think there's, I think rightfully been some conversation about the way that just talking about carbon emissions can leave things off the table. Like maybe it is
Yeah, I mean, it's a
simplifying.
decent proxy, right? It's sort of a
It's
leading
exactly that.
indicator, but there's these other ones that are like eutrophication or something
Hmm.
can be huge for something that actually has a very good carbon profile.
Totally. And it's all about, right, life cycle assessment about putting all of these different impacts on comparable bases. Because, how are you going to look at the difference between we'll say like cellulose board insulation versus mineral wool, or consider something as complex as replacing a concrete structural system with something in timber? So
Mhm.
many variables change. There's all these sourcing questions, these transportation questions. And things like LCA help us make these complex decisions on a comparable basis. And in doing so, designers can, right, target the most impactful decisions. And this gets us back, I think, to what C-Scale is. Early versions of C-Scale really focus at the beginning of the design process. Data scarce environments, very little is known about the building.
Mhm.
You have an idea, an ambition, a general form, and you're trying to ask these questions about what matters most without the data actually to support it. And on the other side, we had LCA tools that required a lot of data, actually very high resolution models sometimes. But at that point, hey, maybe more of those decisions are already baked in, they're harder to change, the design is locked. So C scale
Yeah,
is
some
really
of the
focused
big
on
moves are locked, right? You're
the.
yeah.
And where it's like this classic, BIM, the whole sort of theory of BIM over the last 25 years makes really, we'll say, abundant use of the McLeamy curve. I'm sure you've seen a version of this, right? Like the amount of data you have to make a decision goes up over the course of a process,
Oh, and then sort of the flexibility to actually make a decision goes down.
goes down.
Okay, and
You
I
know what I
hadn't
mean?
seen it, and I didn't want to sound too ignorant, but yes, I certainly understand
You've
the
seen you
process.
it's there were like years where it was in every AIA presentation, and I think it really is like a early versions of CISA were all about shifting left, better, earlier decisions. But obviously, the power of BIM integrated LCA, which is the work that happened at Karen Timberlake that you were involved in Tally that we're now stewarding, and we can say more about that. Really focus on connecting those early decisions through to the 3D design environment, because ultimately, with all of this sort of like wrangling with environmental impacts, the most important thing is continuity. You need to set
Yeah.
early strategies and then make them real. The risk
So
is that
you
you
yeah,
set
'cause
early
you're making big
strategies.
decisions to making smaller decisions, essentially.
One of the mental models that we use is it's the same image throughout the process. You're just increasing the resolution. Whereas the risk is that it's a different image at the beginning versus the end, because you're
Mhm.
using different tools, da da da. So, as much as what we do is about carbon emissions and climate and building performance, it's also about managing data across the design lifecycle.
So you mentioned LCA, and it's how it's important to understand the full panoply of impacts associated with
Mm-hmm.
material, right? Carbon's one of them, but there may be
Mm-hmm.
other things,
Mm-hmm.
other types of pollutants emitted in the course of a material's life, from manufacturing or extraction of the raw materials through to its end of life. When I'm curious about those, like with a name like C-Scale, like clearly you have a carbon focus. Are you using that as sort of like a Trojan horse to get people to think about these other impacts? Or do you find that carbon is, and carbon is maybe the best way to start the conversation? And then you try to sort of open people's eyes to the larger breadth of impacts? Or is the industry gone in such a direction where it's like it's carbon or nothing for most people?
Yeah, it's a good question. The C actually stands for Chico, which is my co-founder Brad Jacobson's dog. No,
Well,
I'm just
you
kidding.
got me there. I didn't see that coming. I didn't
That's our
see that coming
internal
at all.
joke. Is that like, oh, this is actually just named after Chico? Um, hey, there's a way that, yeah, a designer on any given day is balancing 100 things: cost, schedule, design intent. We see carbon as the kind of lighthouse metric for environmental impacts. And then there's all this other kind of color around it. And there are trade offs you'll see when we look at, especially, bio based materials like timber. There's land and water
Mhm.
impacts that are reflected in things like eutrophication that aren't reflected actually in the carbon number. And it's important to see these trade offs. But when we look at the kind of ambition in the building sector to do better, Climate's a big part of it, and we really see this reflected in Lead V5. We see it reflected in policy across the United States. So it really is the entry point. Once you're in, there's a lot of other things to look at. But how do you get the next designer to wrestle with the impacts of their project and try to do better? It's a simple entry point. I think for us, one of the things that is just true of the design process and our work with designers is we're always straddling these two worlds, building easy to use tools for the designers at firms who are otherwise, we'll say, like focused on design or focused on, we'll say, like building science, to get involved without having to know very much, while also serving a more sophisticated portion of the industry, consultants, sophisticated
I like how you
owners.
call them sophisticated. From my experience, I would have called them pedantic. And sometimes when it came to LCA,
To be nice to your users. um, but like our success so far, and I think when we look into the future, is really predicated on our ability to provide easy use tools to people who are novices. And hey, like maybe should be novices because again, like their attention is elsewhere.
but
Good
that's a
guardrails.
fascinating. Like if you think of your origin story, though, it's interesting that that's the conclusion that you came to because you think of EHDD, it
Mm-hmm.
is not a novice type firm when it comes to
Mm-hmm.
sustainability level considerations. They maybe they do need an early design phase tool to understand carbon implications of their design, but they don't need something that's sort of pre-digested or simplified in any way,
Mm-hmm.
shape, or form. So, what did it look like initially in the context of EHDD, and then did it actually morph in
Yeah.
response to sort of like the greater realities of the industry?
Two dimensions to that. The first is just our recognition that it is, while it's important at the project scale, it's not transformative at the industry scale. For LCA to remain the remit of a few shiny headquarters projects that marquee firms do, we need tools and processes that are simple, widely accessible, you know, cheap, fast, and easy. If
Hmm.
we're really going to get a carbon assessment onto every
And this was a
project by every
conclusion that
firm.
EHDD came to, or that C.Scale came to.
This is the interesting, like I loved being at EHDD because there really was to transform the industry, we need to transform our work. For our work to be transformed, we need industry transformation as a tailwind. And this
Hmm.
really like this feedback loop, right, between the state of the industry and the state of what's possible in practice. And that becomes, right, one of the reasons why it actually was very, I think, obvious decision for everybody to spin C-Scale out of EHDD, recognizing that because we see accessible tools for LCA that support the whole life cycle being an essential part of the design process, it needs to be normalized everywhere. And to do that, the best firms can still do the best work, like rise above, but the goal is to raise the floor and
Hmm.
reset expectations. The leading consultants and leading firms, like there's so many axes to innovate on. But if people are differentiating their work on reckoning with environmental impacts, like we're asking the wrong questions because that should be the common ground, not the differentiator of a few.
It's an interest. It's a good perspective, obviously, because you are doing something that has sort of it's a moral good in a sense, right? There's a public good to improving the environmental performance of buildings. So the idea of like sort of sequestering knowledge behind sort of the walls of a given firm and and using it as a competitive advantage is somewhat unseemly in a sense. You're actually robbing from the general public knowledge that could actually sort of improve everyone's welfare.
And our goal is that everybody doing this work is more competitive
Hmm.
for marquee clients to work with the campuses, to work with the hyperscalers than everybody who's not doing it.
Yeah,
Right.
well, you
And this is
mentioned
a little
mid-sized firms, right? Like
mm,
maybe they're not working on the coolest projects, or maybe they are, but this is also introducing clients that may not otherwise think about this type
that's
of
exactly
performance.
the theory of change. Like, first people do this to, build market share, build market presence. Our goal actually is that people need to be doing LCA to defend market presence as
Yeah.
it becomes standard practice. And this gets to all the sort of ways that, the standard of care is defined for architecture firms, which is like the legal, right? Like
Hmm.
definition of good architectural practice is that you're doing at least as good as your neighbors are doing. Well, by making LCA like part of standard practice at these firms, all right, like this sort of thing, and I think there's precedent for it in the way we look at some of the AIA guidance, understanding the impacts of one's work on global supply chains and global ecosystems is part, as we see it, of what should be in the standard of care for architects.
That absolutely makes sense. And I'm curious, when you started this journey, being spun off from EHDD, were there certain assumptions you had about this industry? Obviously it's not that long ago; it's a couple of years now, where you were like, okay, this is the direction our software needs to go.
Hmm.
And if there's ever been an era of disruption, it's been like the last like 18
Totally.
months or a year. Are there things now where you're like, whoo, okay, that's out the window. We're doing a hard pivot here? Thinking it because you shared an article with me that indicates you're thinking very differently about the future of procurement opportunities, material selection, and things like that.
Yeah, I mean, okay, the first thing, like, our first awakening, we'll say, like, was realizing that what is called the AEC industry is actually like a few dozen industries all enmeshed. There's the minerals industry, there's plastics, which is connected to oil and gas,
Hmm.
there's all of these like industries.
You're talking about
Then
the
there's
material suppliers for the AEC
all of the
industry.
material suppliers, but even, then you look at like we'll say like the large clients that people are like the architects are often chasing, higher education, et cetera. And to solve these problems in a meaningful way, what's really exciting to us about AC is that it's the meeting point of all these different industries and players, and every project becomes a node in these really complex networks. And by transforming those nodes, right, we have a chance to transform the industry. You mentioned AI transformation. I think that's super important to note here because it is changing the way buildings are designed and delivered.
Is it so? What are you seeing? I mean, you're probably in a really good front row seat. Like, how is it changing the design and delivery process already?
I think we'll say that there's a balance here between what is the future that feels a little better defined and the reality at present.
Hmm.
You know, the near term uses of AI that I really see being powerful are there's a lot of work to be done on just QA/QC of drawings, responding to RFIs. From our perspective, our differentiator for a long time has been, you know, early predictive models of buildings to help fill in all those gaps early on.
Hmm.
I think that's something we'll continue to see in AI solutions in the industry is data solutions that give better insights earlier. And again, like fill in the initial picture and allow people to iterate. That's been our kind of like AI strategy for a while. The way we see the future going is that there's so much work that goes into putting a building together. Some is really important for architects, individuals, engineers, owners to pour, their really close attention into, and some is rote work. And actually, when we think about things like optimizing specifications for low carbon materials, a lot of this, Roderick, is rote work. There's good
But it's
solutions
really
out there,
important rote work.
totally. And I
And
think
do
this
you
is
think it
where,
needs a person, or do you think it's one of those where, because you think about the specifications, right? You're trying to look, you have a performance spec
hmm
that's associated with that, but you also have a sort of an aesthetic component
hmm
associated with it that isn't really captured necessarily in that performance spec. And then you also have a budget element associated with it as well. So when there's something goes out to bid, it's got to look like this, cost like this, and
yeah, yeah, and
perform like
perform
this.
like that. And there's always, I think, because this is why, like, you hire an architect, going to be people involved in that loop. Design intent is really important, defining it, reviewing it, balancing trade offs. And there's all of this document review that is work that like people should not have to be doing day to day. All of the sort of gathering of information for different submittals. And I think too, we'll see like, yeah, there's places where all of those things matter. And there's other things like of these six, insulation products, here's my criteria. Design intent, less of a issue. We have some building science concerns. We have some carbon goals. Like what's best from that palette, and the ability to make recommendations. Be we'll say proactive in finding the best material instead of just needing the architect to sort through all of the documentation is I think something that's going to be really exciting here because people sort of know the shape of what they need, and if they don't, enough buildings have been built that we can look at patterns and say this sort of building tends to use this sort of installation, and giving these recommendations, I think creates an interesting first layer for what the future of specifications will look like. And with this, like where it's headed in the longer term, maybe there is a future where there's engines like C.Scales that help with understanding building components, selecting optimized materials along the right axes, and building design tools that people are building to automate some of that initial process. And I don't think it's, a 2027 problem to do this sort of like a fully automated flow, but there will be ways that specifications and the market for material procurement will be increasingly shaped by automated systems that talk to each other with human consultation, but more
So,
and more.
well, that makes sense. I mean, I'm just thinking from my experience working on, say, a really large project, right? There's this huge backlog of RFIs and things like that. It's like
Uh-huh.
I got to chew through these, right? If there's ever an opportunity for that, it could be huge for this idea of machine to machine sort of negotiation and decision making. But to do that, there's an element that you mentioned, that you have to not only have, I think you said something, you're plotting things along sort of like a performance continuum, but where someone wants or feels the appropriate place on that continuum for the material for their perspective is going to be
Hmm.
different.
Totally.
Some people may say, "Oh, it's straw bale or nothing because I want the most sustainability
Yeah.
thing," right? Other people are like, "No, I want glass because I want beautiful transparency and lightness or whatever."
Hmm.
And so there's a judgment call that's baked into that type of decision making. So do you see a future where something like C-Scale combines sort of like the judgment and aesthetic personality of the user or the user firm and is part of the decision making layer so that C-Scale maybe is kind of like the LCA expert in the room, but the architect is able to teach it what it needs to know about its way it should think about design. So C-Scale actually becomes sort of attuned to the user. And sort of it adapts to you and your methodologies and your priorities and your decision making framework. So my C-Scale experience might be very different from another firm's C-Scale experience.
I mean, you see how like the changes in the last few years begin to make something like that possible. And then the question becomes, where is that design intent registered? Where is it reflected? And we see that as being, or like Cscale as it exists today as a cloud platform. Tally as it's being, the next version of Tally as it's being developed and released is also a cloud platform, but it integrates into the BIM
And it says
environment.
integrate to like into was I don't know what it Autodesk I think it's the new format is what they call in BIM 360 now or something like that.
Our It'll be, Revit is one, like the BIM environment that we're really excited about. Probably directly in because you just have like actually richer access to
Hmm.
the elements, and it's by interpreting the BIM data that you're able to understand, get a hint at what the design intent is. And this gets to this larger question of like where agency lives. There's things that I think the first versions of Tally Get Reuse will just be interpreting the design intent of the stuff in the model. Somebody models a 6-inch generic wall, you know, okay, the specs say this, the early phase model in C-Scale said that. We think we know that the 6-inch generic wall, like what you didn't say, but what you probably mean is that it's gypsum, metal stud, with
Yeah,
fiberglass
here's our
mat. And
recommendation, approve or
exactly.
not.
This is probably this is what we think you mean.
So you sort of like an autocorrect or an autofill, if you will,
And
to some
then,
degree.
you see how that grades to, hey, we think what you mean here is a steel stud wall with fiberglass insulation. When you look at these fiberglass installations, have you considered these three options that are functionally equivalent but have a lower carbon footprint? Because this could be an easy substitution. And it's the ability to do the interpretation and make recommendations where we see the next level of value being unlocked here. Because
So
how would you find
but
those
the
recommendations
value
otherwise?
for where, right? I mean, the part of it is you better have a very good reputation of trustworthiness on one side, because that is a huge opportunity to put your thumb on the scale when it comes to procurement decisions.
Hmm. Well, this is where we'll say, like, we, because of, as a mission driven company, we do want a thumb on the scale towards lower carbon outcomes. Like we want procurement relationships in the built environment to change, Roderick. They need to.
So you want to encourage things that are going to have a better carbon performance
You know,
potentially.
like we have a horse in this race, and it's the decarbonization of the built environment.
But if you're doing that, you still need to acknowledge that these decisions are reflective of a variety of requirements, right? Like you
And
said,
that's
there's an
why
aesthetic cost, right? So,
exactly.
do you have to bring all the rest of that into play, or do you let say, you know what, we're just going to do this one piece. You're responsible for the rest. But otherwise, you might be recommending things like, some sort of reclaimed timber that's outrageously expensive, is brought up out of
Not
a
available. Yeah,
yeah.
yeah, yeah. Are artisans nailing toothpicks together
Yeah,
or
exactly.
something?
Like recovered nails from, farms from 200 years ago. I don't know.
Yeah, yeah, yeah. Well, and that's exactly why, like on our, roadmap for the next year, it's really about recommendations, surfacing better
Mhm.
alternatives. And really like that is, I think I think you're right here that there's real responsibilities, like real liability and risk actually that the person stamping the drawings takes on
Mhm.
for ensuring that the materials selected meet the requirements of the building. And I think that's like, C-Scale is not going to be stamping those drawings, but C-Scale is interested in helping designers decarbonize their buildings. Like this is an outcome that our users want and that we want, and is 100% an invitation to specify materials differently and to
Oh,
take
for
those
sure. But you
little
got to give
design.
them all the information, right? It's tough to
Totally.
make a decision with just one perspective. It's like, think of it. I'm coming from the visualization side. So I
Mm-hmm.
work at Chaos and we do a software. It's pretty heavily used called Enscape, pretty
Mm-hmm.
heavily used in the AC industry. But it's just how something looks.
Mm-hmm.
And if you just made a decision based on how something looks, it could end up being, from a sustainability perspective, quite poor performing, right? And then if you did something that just based on sustainability, it could be really ugly. So it's like, you need to bring all these pieces together in a
Yep.
way in which makes for actionable decision making.
And this, like, I think this gets to, when you think about the role of tech in the design process, or just like the AEC tech ecosystem generally, our approach is like you know, we want to play nice in the sandbox with other people who want to do the same.
Mhm.
We're really interested in ecosystem approaches. We've had a great Autodesk relationship for the past few years. Hey, like the way the rendering is going to like, the way it'll shimmer in the evening light, like that's Chaos's responsibility, and that should be related somehow, I think, to the same
Yeah, because it's a
data.
material you selected is making a shimmer like that. And if it turns out it is some type of a very carbon intensive manufacturing process to deliver, you probably want to know that.
These become these interesting like points of integration between these. I think, there there be an application in the next 5 years that claims to do it all? Probably. Will it actually do it all? Maybe not. And I think here, like, it's all about interoperability. How do we make sure, the like, we'll say the bone to pick LCA people might have with the rendering software is that there's all these places where you have the windows rendered
Mhm.
as like stainless steel, so they have the right kind of reflectivity.
Oh, for
You
sure,
can't
right?
map
That's why you
those.
need these different domains of expertise.
Exactly.
We may do things to make it look as beautiful as possible, but it's not necessarily as realistic as possible. I mean, you could if you wanted to, but those aren't the renderings people
But
want.
you're 100% right that there is, this is the magic of buildings in a sense, is that there are these really contingent processes that balance, 100 different stakeholders and dozens of different like metrics to land exactly the thing, and be able to open it on whatever that is, like September 20th, so that students can show up on September 24th to the new
Yeah,
campus
on
building.
time,
Like,
on budget. It can be
uh-huh.
tough. I mean, there are incredibly complex, but I like this idea of, if you think about building the buildings, as you said, it's this absolute Gordian knot of suppliers and that are delivering the materials, and then it's all of the people that are involved in the design and construction process, right? A whole nother small army of individuals.
Hmm.
Why would the software, in some ways, be any different? Like the idea of one person just doing it all is about as ridiculous as one person being like, "I'm going to build a high rise, and I'm both the owner, I'm the contractor, I'm the material manufacturer, and I'm the designer. Oh, and I'll be occupying it as well," right? Like that just doesn't happen.
Hmm.
And you think about, well, each one of those people has a different expertise, a different role to play. And you
Yep.
think about it in the software side, it's an interesting point. You're like, we're open to partnering. It's like, well, yeah, I guess in some ways, partnering is kind of key because you need to, in some ways, match the way of the diversity of inputs and
Exactly.
stakeholders on the building side or
And the
construction
question
side.
becomes like, what is the connective tissue that folds all these different stakeholders together? like we see interoperable data as being a really essential part of this. So that, hey, the data coming out of C.Scale, out of Tally can be useful to the people building the cost estimates. Here's the cost estimate that they're doing on, their unit
Yeah, so
cost
you're saying I don't
basis.
wanna do everything. I just wanna make sure that my data plays nice with other people's data
And
to
it's
allow for that.
understanding those flows of data and the way that data connects, has the potential to connect all these processes. This is where I think we'll see really interesting unlocks so that we can stay in our lane and focus on decarbonizing construction. And then that data goes to the cost estimate and they say, okay, interesting. Like these six things, all good, cost neutral. This seventh thing, this artisanal mass timber product, is like,
Yeah.
that's a no go. Can we sub here? Here's what the substitution needs to look like. Okay, interesting. Like now we have more parameters within which to make recommendations. There's a lot of fragmentation in data, and this is the other thing we think in the age of AI will change
So
is
that's a great question though, like with data exchange, right? There's been all these sort of fits and starts like
Mhm.
GBMXL
Yeah, yeah,
formats and things
yeah,
like that, right? And people using various programs to try to exchange data around AC, but it's really messy because the data is in like a lot of different formats. Like right
yeah.
now,
Mhm.
you have meeting notes and minutes, and then you might have some Bluebeam documents, and then you might have some BIM drawings, and you have some CAD drawings, and I don't know, you might have someone's sketches. Like, I mean, it is a mess of
Yep.
different things. Like, where do you see that data piece going? And what does interoperability mean from C-Scale's perspective? Like, are you looking at certain data formats or certain data partners to develop a format, or like open BIM standard, that sort of thing? Like, what are you
There's
thinking?
different efforts sort of underway, that we're a part of with some of our partners and wider industry kind of efforts to do data schema harmonization. We're really excited about. The other thing we'll say is that some of it is about the data schema and making it interoperable. The other is about just putting decisions in context. And context is exactly one of these things that, LLMs are really good at. So
I mean,
here
they're
you
good at
are.
the data piece too, though, right? I
It's
mean,
true.
that's the other
Yeah,
thing
yeah,
is,
yeah,
how
totally.
how good of a schema, a universal schema, do you need when you can just sort of make it AI's problem?
And like I think that's we'll see all sorts of ways that file organization, file indexing changes in AEC so that, what we really want is when we make those four recommendations for different installation products, it can be within the context of the whole project. And that context will include obviously the BIM, what we
Mhm.
see in BIM, the specs. Hey, maybe there is, a meeting log that's important to reference that's going to give us some insight into the way that decision should be made, but the more context we can build
Don't forget
around
what it looks like.
that's your problem.
Yeah, no, but that needs to be part of the
No,
context,
of
right?
course.
If you're
Yeah,
recommending a
of course.
substitution, it needs to look the same, and that's kind of one of the interesting things. Like, there's a tendency towards like real-time tools in the industry or
Yeah, of
AI
course. Uh-huh.
visualization, and I think we're going to see a reemergence of the importance of true photoreal visualization, because now I really need to know if I'm going to be substituting out this limestone for that one, it's got to
What does
meet
it
a certain
actually look
visual
like?
spec, right? And that
Yeah, of
spec and
course.
that difference in visualization has to be real enough that it might even have to be read by a machine and says, "Yep, that looks
Hmm.
the same."
Well, and I think like, this is a part of the conversation. I think a part of the industry where there are more questions than answers. Putting aside, we'll say like what some people are prognosticating. There's lots of ideas, but we'll like, I think it's really an open race actually to see how these things crystallize. But the potential is clear that the design process like will change, that there's places where we need designers and engineers to be putting a lot of close attention. And there's other decisions where machine assist or machine substitution starts to become possible. And in the way that like, you know, people are making material decisions because it's what they've always done using legacy specs and the products whose reps have been knocking on their door, every 3 months, like for dropping off cupcakes at Christmas. Like
Hey,
this is
that
important.
matters.
It does. But hey, like
As I
maybe
always said, it's
that's
like your fee coming back to you in a really inefficient way. It's
uh-huh. Like but this also might be covering up better opportunities, products that are applicable, a project just like yours down the road, they use this fluid applied flashing.
Oh, for sure, and that's the thing I remember from the Tally days. I was like people would always ask like, "Oh, what's the cost?" I'm like, "You don't understand, like, some of these materials, like, when we're looking at different insulation options, you have ones that are, like, 10 times worse. They look the same, they cost the same,
Hmm.
they perform the same, and yet this one was atrocious." It was like, like, do you really just wanna pick the bad material? Because
Totally.
it's like, no, and that's where I think that some of these things where, like, with AI, it's like it can make some decisions for you or nudge you in the right direction really efficiently, and this idea of the scale that you were talking about, like, how do you really scale something like this? Well, part of it is you don't really require anyone to have any effort to get the information they
And
need to act on.
and I think we need to sort of divvy out here, right? The decisions we'll say that are straightforward for a machine to make and decisions the machine should never make, and the whole gradation in between. There's places where actually just, machine driven recommendations make sense. They're low risk. There's just better materials out there that compete on cost and performance and can be easily substituted. There's other places where it's like trust but verify. And
Mhm.
there's other places where like don't trust,
Yeah,
actually,
don't
where it
trust,
needs
really
to be
get
the
into it.
person in the. And I think out of every 100 decisions, like which proportion fall into which of those categories will shift and will continue to shift. And I think we'll see the bottom buckets, ideally, we'll say like get a little bigger so that designers have more time to think about the things that matter most and the things that really move the
I
design
mean, it's
forward.
we're getting a little shy on time here, and maybe people are want to hear about other things. But I'm curious from this perspective. Time focusing time on things that matter most, right? That's like craft. That's sort of
Hmm.
the art of delivering a beautiful building that's going to have real permanence, that's going to inspire the occupants. I'm seeing a challenge with a lot of LCA in that it requires data around the manufacturing process, and as you get to specific products, there's a certain scale that accommodates the collection and generation of that data, both because you can
Hmm.
afford that process, but also that, the process is well enough defined. And as you get into more sort of niche materials and craft things, the process isn't necessarily large enough in scale to justify the cost of performing an LCA. It's maybe not regular enough of a process, a lot of one offs and
Hmm.
things like that. Do you feel like there's a risk of these types of processes pushing people away from maybe materials that maybe reflect craft sort of unusual wallpaper, if you will, and things like that, as
Uh-huh.
opposed to things that are sort of more commoditized and have better data sets
Yeah.
around
I
them?
mean, we'll say it this way, there's a lot of uh, great materials with awesome sustainability stories that are doing a lot of work to transform legacy industries that don't have the scale. We're doing environmental product declarations and carbon
Hmm.
footprints make sense or are cost effective. And there's a lot of materials that have scale, can afford those things, but hey, might not move the needle the right direction. We see the ability to understand like demand as it flows through buildings, all these specifications as being something to leverage to open up the market so that there's competition along the most important axes to move these smaller tier manufacturers forward into the market. Like, why do people get EPDs? They get EPDs because there's a project that needs them. It's of a large enough scale where it
Yeah.
can fit into their margin, right? Like, why can't these novel manufacturers find those projects, and why can't those projects find those novel manufacturers? It's this sort of matching problem that exists.
It is, and also the EPDs themselves are a process where you mentioned like a full scale LCA is like pretty intensive, right? And
Hmm.
that was sort of a boutique firm consideration. And in the same ways, an EPD is pretty expensive.
Yeah.
I mean, and it's a manufacturer that has a clear and demonstrated need for that EPD. It'd be great to see opportunities for what C.Scale has done for the application of decision making, or carbon based decision making and building material selection. That sort of thinking being brought to the EPD generation
It
side
is.
as
There's a
well.
couple cool companies, like 1 or 2 in Europe, 1 or 2 in the US working on this, and we see that, like, we've worked with some of them to get sort of pre-EPDs out there.
Yeah, it's
That's
sort of
just a.
like an EPD junior, like a provisional
Exactly.
EPD or
Yeah,
something.
exactly. Here's the LCA. You can sort of use it as a sales document, like, "This is not an EPD, but, like, give us the project where we can, hey, do the real work,"
Hmm.
and, like, we'll sign up, we'll do the EPD as requirement to get the bid. Uh and but it helps them get them in the running because it is like, yeah, Roderick, like we need to create a better market for these materials. To do that, we need to aggregate demand signals from architects and have the architects just like, be exposed, at least on occasion, to these better alternatives that exist, lest we end up specifying the same business as usual materials for the next 50 years.
That's true, and there's a pretty good risk of that, to be honest. It's people will specify what they know works,
Hmm.
and not necessarily want to risk exploration.
And like risk is the core of that. And I think like that's the thing that's always countervailing here is we need to both like, the mission is
Mhm.
to transform legacy industries while also acknowledging that a lot of the ways that risk is handled in the built environment, how manual it is, how people pick up the phone for the, things that aren't covered in the contract, these are features and not bugs of a very litigious and person driven
This is
industry.
like the argument that America's democracy is effective in the fact that it's so slow, so things don't happen too quickly.
And this is the balance. And this is why some decisions like, yeah, you know what? Like waterproofing details, like, not our circus, right? Like enough liability is involved there that like
Mhm.
probably a bad place actually for us to make. But other things, interior wall coverings, different details as they come together in interior spaces, we'll say some parts of the cladding detail. Like we have opinions about what's better and what's worse because you can see the clear performance differences from a carbon perspective.
I like that, and I think maybe that's a good place to lead is or to leave rather, is that, C-Scale is like is a trusted partner, and I think that's an interesting approach that you've taken there. Is like, we provide data from a perspective of wanting to implement change, as opposed to just selling a software, and that the data we provide is something you can trust to point you in the right direction from a carbon and LCA perspective.
And this gets to, I think one of the by having opinions about this, like this is one of the things I think that we're really happy to be in the market and working on so many with so many firms. There's going to be days where we really nail this, and there's going to be days where like, we get emails saying, "Hey, like you made this recommendation. This wasn't the right thing to do." Okay, cool. Like, and
Well, those
really
are
so
some
much of it.
nice emails. You should see some of the ones I get. That's pretty good.
But there's a kind of openness to the industry that's really important as we're building because, yeah, it's a delicate balance, everything here. So the best we can do is just to like stay open and stay engaged.
And would you say for, someone listening that hasn't used C-Scale or hasn't dipped their toe into the LCA or embodied carbon waters, what would you recommend they do?
We make it really easy to get started. So much of what we do, we offer for free to designers. So use C-Scale, heck, use another platform. Like the best thing to do is to get started somewhere. And I think, so in terms of just like a process, like check us out. It's free. The other thing is just like consider it as you're walking the job site, as you're sort of like filling out your schedules, just like think about where these things come from and the effect they have on the world around us. And I think that sort of investigation that people sort of end up doing naturally, just as in the course of their work, is really the starting point, I think, for so many people's journey down.
Be curious, ask questions.
Ain't that it? Uh huh.
That's
Designers are good at
perfect.
that.
Well, this is great. Thank you very much, Jack. This has been a wonderful conversation. Really appreciate it.
Thank you, Roderick. I really appreciate your time.